Hi, I'm Patrick Angelis. I am a principal solutions architect here at Redpanda, and I'm going to talk to you about elastic streaming using remote read replicas. So a little bit about me. I've been working with distributed systems for years now. Not a red panda personally, but there is a red panda living next to me in the Prospect Park Zoo in Brooklyn. And we're also both nocturnal animals and studied Kafka. I studied literature in school, and we are both afraid of zookeepers. So I'm to intro remote read replicas. I want to put some context around it, and I want to bring up this use case called streaming fraud detection. Um, so in fraud detection, uh, you have this is a fairly generic or general component view of the different things that are involved when you're doing fraud detection, right? First of all, you have a point of sale system where perhaps a customer would swipe their card, and then that goes and does an authorization request to a payment gateway, right? And we're talking about credit card payments here, but this could be applied to any kind of fraud you're looking for. But anyway, a potential transaction goes to a gateway, and then that gateway basically checks, it consults a scoring engine. Basically it takes the data that it got, it adds a few more context to it. Like if it's a credit card transaction, then it might try to include, account balance and other information. Usually getting it from a database, and then that whole request is packaged together and sent to the scoring engine, which takes all that data, applies a score to it, and then if that score exceeds a certain threshold, then you can kind of consider, like the gateway can take an action to approve or deny that request, right? And then that whole thing, if you're talking about payments, has to happen really fast, right? In under a second typically. And so there is that, right? There's sort of like a real time aspect to it. But on the back end, right? Like where do these, how do you actually score for the fraud, right? Like you have risk models. And risk models are built out of machine learning algorithms that are basically put together by data scientists. And what they do is they take a whole bunch of historical data, and it could be like the detailed history of like transactions that you've done, maybe roll-ups of account balances on a daily basis or monthly basis and that sort of thing. They convert them into features, which then serve as input to the training of these models, right? And they kind of do this in the background. And it tends to touch a lot of data, right? And they do lots of transformations to get the data to the shape they need. And then in the end, they come up with a risk model, which then gets published to that scoring engine, and it goes live, and it gets applied to any subsequent transactions that come in. And the interesting thing about this use case is that it has kind of an operational aspect, kind of a real-time, component to it, where you have to respond in near real time back to the requester. And then there's an analytical component to it. This is the stuff that happens in the background. And analytical workloads tend to touch a lot of data. So it's heavy reads, and it also can be very ad hoc, meaning it's unscheduled. You never know when a data scientist kind of wakes up and gets an itch and says, "Oh, I want to try out a new fraud model that I dreamt about last night. Let's do some experiments." Right. So it's kind of ad hoc by nature, and it happens at the speed of the business, right? Whereas operational workloads happen at the sort of like basically on a very regular basis, and you might have peaks and valleys in that pattern, but it's somewhat predictable because you have a historical record of that activity. So really two different workloads. Now, if we want to convert this into kind of a streaming paradigm, right? Like you'll notice in this diagram, we have databases involved to kind of like persist the data. You have like an operational database and an analytical database, which is a data warehouse. These are both kind of geared and optimized for the specific workloads that they're serving. When you convert that to streaming, what happens is you might take some of those tables and turn them into topics, And so we still have kind of the same components in play, but you might use, let's say, a pub subsystem like Redpanda to to basically kind of record and log these events and use that as the conduit to exchange data between the database, the scoring engine, the different services that are involved in this architecture. And why would you want to do this? Because sometimes, in general, the faster you can react to incoming data, the better, right? Some fraud models are actually based on time. Like, for example, if I swipe a card now versus, and then I swipe again 10 minutes later, there are fraud models that can basically check whether it's actually physically possible for me to go from point A to point B in 10 minutes. Another benefit is on the technical side, by decoupling some of these microservices, you do have an easier time at scaling them individually and also improving them kind of independently of each other, right? So there is a lot of potential benefits there in terms of improving applications. And then in this architecture, you might choose to keep your transactional database and your analytical database as well. But in general, when it comes to topics that are, moving, they all tend to go into one cluster, right? This is kind of how you would probably build this prototype. And the issue is you kind of wind up with a mullet, right? You're kind of doing your operational transactions in the front, it's kind of button down business side SLAs. And in the back, you got these wild and crazy data scientists kind of like having a data party. And kind of munging this data as best they can. And kind of combining that into one cluster, you wind up with a mullet, right? It's okay for prototyping and development, but you shouldn't really go to production with that. And the typical way that, the issues with that is first of all, you get poor workload isolation, right? You will have your ad hoc analytical jobs interfering with your operational SLAs. And that can be an issue, obviously. You could miss your sub-second response going back to the point of sale system. So a lot of people compensate. I mean, you could compensate by over provisioning your cluster so that you can accommodate and kind of satisfy your operational SLAs while allowing for ad hoc workloads. But obviously that's not very cost effective. And most of the time you might wind up with a cluster that's really underused. And so some people move to this to go to production. A lot of people go to a mirrored cluster solution where you take your operational, you sort of have a notion of an operational Redpanda and an analytical Redpanda. And that's great in that, what you do is you would replicate topics from one to the other. And so they're effectively mirrors of each other. But what you would do is what you get out of that is you get complete isolation on your operational workloads. And you have a separate analytical cluster where, your data scientists can basically do all the analytics they need without interfering with your workloads. But the issue with that is that you're kind of still stuck at a fixed capacity, right? The real problem is your analytical workloads are unpredictable. I mean, there are some like producing daily reports and that sort of things, that sort of thing where it's okay. But in general, the utilization profile for analytical workloads is kind of hard to size for. And so what we've done with Redpanda is we kind of effectively enable elasticity for streaming analytics. And we do that through this tiered storage feature, which I'm sure you heard about from earlier in the day. And just brief overview. Basically, we have the ability to archive your logs into S3 and transparently retrieve them. Thereby reducing your storage costs. What we also do with tiered storage is we allow other clusters to actually read that data, so operate on that data in read-only mode. And you do that by creating a read replica topic on an analytical cluster. And what's great about that is you can stand up these clusters dynamically. Like, let's say I wake up today and, SEC called me and they need to do an audit of all the transactions that I've done. I go into, I spin up an analytical cluster and I go into S3 and I produce a report of all my trades, for the past 2 years. Boom. Um, and so in this way, you can have an operational cluster which is completely isolated and it's sized to meet your peaks, but no more. And you can have any number of these analytical clusters that you can bring up and down. You can have as many as you need and take them down to zero when you're done. So that provides a real kind of a cost savings in terms of dealing with analytical workloads. I have it's not so much a demo, but like you can try it yourself. If you go to that URL over there, there is a Docker Compose available, and you can download it, have Docker installed in your machine. What it does is it sets up two Redpanda clusters. One is acting as your operational cluster, and the other one is acting as an analytical cluster, and it shows you how to set up read replicas. So give it a try. And that's it. Thanks for joining.